Hi guys, in the last video we talked about coordinate geometry. Now we'll see about functions in this video. So let's begin. In the most generic terms, imagine function as a machine that accepts some inputs and pushes out some output, but the catch is that the output has to follow a set of rules and see what the input is and then act accordingly. In math, when you see f of x equals to x square plus 36x minus 64, it just says what the rule for this function is. And remember, last time around we were also in need of something similar to this, a way to constrain the degree of freedom for point. But first of all, let us define a function in a more formal way. Suppose you have a set x and set y. A function assigns every value present in set x to some value from set y. It may or may not be unique. Let us take an example to understand this. Let us take a function that gives you the area of a square plot. So if you give it the side length, it will give you this area of the square plot. Let us say our set x has 5 values, that is ranging from 1 to 5, and also set y has some particular values. So every input from set x will be assigned to some value from set y, and we all know what those values are. Those are squares of the numbers. So now let us modify the function. This time our new function will give squares to any input you give. So let us also modify the set x. We'll include negative numbers this time. Therefore, the set x becomes minus 3, minus 2, minus 1, 1, 2, 3. And set y is also modified accordingly. So in this case, we see two values from set x will be assigned the same value from set y, because square of a negative number is also a positive number. These types of functions are called many-one functions, and the first function which we considered was a one-one function. In other words, if two inputs have same output, it's a many-one function. Now hold this thought for a moment and consider another example. This time is the same machine that has 5 buttons numbered from 1 to 5, and the screen displays two things. First is the square of the number, and the other thing is number 0 that is displayed due to some internal error in the machine. So now our set x is still 1 to 5. But now set y will be modified because you have a new output that is 0. So in this case, the output 0 cannot be mapped to any of the 5 inputs, or this output has no input. These types of functions are called into functions. In a more formal sense, if at least one element from set y doesn't map any value from set x, it's an into function. And the counterpart of this is called the onto function. So now we have addressed the definition and nomenclature for a function. So now let's understand it mathematically. Let us bring back the first example and remove all the physical parameters from it and focus only on the numbers. A function that returns square of the input. Mathematically, that is f of x equals to x squared. And this is interpreted as a function with x as input that will return x squared. Now let us bring back our old problem of constraining the degrees of freedom. And now let's do some cheeky work. Let us replace f of x with y. Or now the equation becomes y equals to x squared. Technically speaking, we are just mapping the output of the function to a new variable y. But if we consider x and y as the coordinates of the plane, This way we can establish relation between two coordinates, and this is how functions are displayed on the graphs, where for the input x, the corresponding value of f of x, which is y now, is marked and all the points are plotted on the graph. And then a curve is fitted between these points, thus giving us the curve of the function. So this fundamental concept of displaying a function on the plane of space is an essential and ever important tool in modern engineering. Now let us look at some common examples of functions being plotted. The first example which we took, y equals to x square. The curve plotted through this function is a parabola. Next example we take is y equals to square root of r square minus x square. So the curve plotted through this function is a circle. So the more common form of this equation is x square plus y square equals to r square. Now let us learn one more trick before closing this video. So now instead of mapping y equals to fx, we will map y equals to minus of f of x. So now y equals to x square becomes y equals to minus x square. So therefore magnitude of y doesn't change, but all the points are just going below the x-axis, or we just flip the curve about x-axis. In a more formal sense, for every y equals to f of x, y equals to minus f of x produces the mirror image of f of x about x-axis. And similarly, y equals to f of minus x produces mirror image about y-axis. So with this basic understanding of functions, we can explore mathematics in a much more deeper sense. Until then, thanks for watching.